Welcome to The Explainer. So, have you ever stopped to wonder how a perfectly beautiful, clear blue sky can just turn into a raging thunderstorm in what feels like a few minutes? Well, today we're going to dive into the invisible forces swirling all around us in our atmosphere to really get a handle on the science behind our daily weather.
You know the feeling, right? You leave the house, it's sunny, not a cloud in the sky, and then bam, you're caught in a sudden downpour. So what is going on up there? To figure that out, we've got to start with the basics of this massive invisible system that basically runs the whole show.
Okay, so first things first, we need to understand the stage where all this weather drama plays out, the atmosphere. What in the world is it exactly?
Well, the simplest way to think about it is it's just the air all around us. But it's so much more than just empty space. It's a very specific and absolutely crucial layer of our planet.
Right, so it's not some endless void stretching out into space. The atmosphere is actually this surprisingly thin blanket of gases just wrapped around the Earth. And this one blanket is responsible for everything from a gentle little breeze to a monster hurricane. So now that we kind of know what it is, let's break down what this atmospheric blanket is actually made of. I mean, what's in the air that we're all breathing in right this second?
It's the next logical question, isn't it? If this giant blanket of gas is creating all of our weather, what are the key ingredients? What's the recipe for air?
And this is where it gets pretty surprising for most people. We obviously depend on that 21% oxygen to live, but look at this. A whopping 78% of the air is nitrogen. It's mostly just a stable filler gas. But you know where the real weather drama comes from? That tiny 1% sliver of other gases. So, inside that tiny 1%, there's one component, water vapor, that has a huge, outsized impact on our daily lives. So what makes it such a big deal?
To put it simply, water vapor is the lifeblood of our weather. I mean, without it, the sky would just be clear, all the time. No clouds, no rain, no snow, nothing. It is the one ingredient that makes all precipitation possible.
All right, next up, how do these gases, all moving around, actually create the weather that we see and feel every single day?
You know, it's interesting to think about it this way. Weather isn't really a thing, it's more of a condition. It's like a snapshot, a status update of what the atmosphere is doing at any given moment. And the one thing you can count on is that it's always changing.
And this interaction right here, this is a fundamental recipe for weather. You have warm, moist air, and it rises. As it gets higher and higher, it starts to cool down. And that cooling process literally squeezes the water vapor out, forming clouds. And eventually, you get rain.
And that constant state of flux is what answers our original question. A morning can be sunny and the afternoon can be rainy for one simple reason. The conditions in the column of air right above your head have changed. The air is never, ever sitting still.
So how do these atmospheric changes translate into the specific weather we actually feel? You know, the storms and breezes of the world. Let's look at a couple of really clear examples.
Okay, picture a hot summer afternoon. The sun is just baking the ground, which heats up the air right above it. This hot, moist air starts shooting upwards, and that rapid climb is exactly what builds those gigantic, towering thunderclouds in just a matter of hours.
I love this sponge analogy. It's the perfect way to picture it. As more and more moisture gets sucked up into that rising air, the cloud just gets saturated. And eventually, just like a totally full sponge, it has to let go. It has to release that water as rain.
And this same idea of moving air also explains something as simple as a breeze. It's not random. It's just air moving from a high-pressure zone to a low-pressure one, all because nature is trying to find a balance.
Think of it like a crowd packed into a small room. As soon as a door to an empty room opens, people naturally start to move into that empty space, right? Air does the exact same thing, flowing from those crowded, high-pressure areas to the empty, low-pressure ones. And that movement, well, that's what we feel as wind.
So, now that we've got the basics down, we can see how to use all this knowledge to basically become our own little weather detectives.
And this is why it all matters. Understanding the why behind the weather helps us predict the what's next. Seeing dark, heavy-looking clouds isn't just a casual observation anymore. It's a direct clue that the air above you is loaded with moisture and might not be able to hold on to it for much longer.
Yeah, really. By starting to pay attention to the clouds, the wind, even just the way the air feels on your skin, you can start piecing together the clues the atmosphere is giving you. You can get a pretty good sense of what the weather might do next.
So here's a little challenge for you. The next time you step outside, Don't just feel the weather. Look up and really observe it. What kinds of clouds do you see? Is the air totally still or is there a breeze? What do you think the atmosphere is telling you?